Hello and welcome to this tutorial where we're going to have a look at gears and how to make this contraption work and look like it's working correctly with all the gears nicely meshing together. The contraption will be driven by these two pistons, so we're going to look at timing the animations of the pistons along with the animations of the gears, and all of this will be available to players. All they need to do is just interact with this console here, and that will start the contraption, and then the bridge will move across so that the players can reach the other side of this chasm to this scary looking temple. Okay, so let's look at how we go about doing that. I'm going to use advanced mode because there's going to be a bit of programming. There's also going to be quite a lot of gear related maths, and that's maths that applies to these gears, but it also applies to the real world. So if you figure out how to do this stuff and get the method down for how fast the different gears work with each other, then that's something that you can apply in other parts of your life. Okay, so to start with though, let's start using these pistons. So these are a little bit more straightforward than these gears over here. If I click on one of the pistons and scroll down, I can see it's got this copy animation names box, and that means that this piston has animations already inbuilt in Crayta. And I can play those animations using just a single line of code. So let's do that. Let's add a script to this piston and let's play that animation. So with the piston selected, I'm going to click Entity, Add Script, New Script, and this is going to be called Active Animation Script. And I'm going to scroll down in here and just open that script up. Okay, just for now, I'm going to do everything on the Init method. And then further down the line, we'll look at how we can activate all of these this functionality from that console. But to start with, let's use the init method. So in here, I'm going to do self, which refers to the script, colon, which means I'm going to call a function on that script. The function I'm going to call is getEntity, which essentially gets hold of the thing that this script is attached to. So that would be the piston there, getEntity. And I want to call a function on that piston, on that entity. So another colon. And the function I'm going to call is play animation. I'm going to use the play animation looping actually. So I'm going to use play animation looping, open brackets, and it's asking me to pass in a string animation name. So a string is essentially a series of alphabetical or numerical characters in between quote marks. If I hover over copy animation names, you can see that there's deactive, which means not working, or active in between quote marks, and that means that this is that would be the animation we want to play. So let's play that animation. So capital A for active, make sure I spell it exactly the same, and then end brackets like that. Notice the quote marks, and the quote marks turn it red. So that means that this is a string rather than a line of code, or rather than something that the game's going to need to run, or a function or something like that, because it's color coded red to show that this is literally a string. These are the characters that you're referring to. Okay, so play animation looping active. Let's go back in here. Now we don't need to actually test the game to test that that line of code works. If we go with this entity selected, if we scroll up in the entity editor to the simulate button and check that, we can see that it starts playing that animation straight away. Hey, there it is. And it's doing that because it's on the init function. So that's why we're using the init function to get all this set up. And then we'll move all this code later on to a function that we can call from somewhere else. So yeah, that's what that line of code is doing, is essentially playing that animation. And it's exactly how I expected it to work, which is quite handy. This one isn't playing, so let's make it do that. With this one selected, I'm going to add the same script to that one, active animation script, and I'm going to click the simulate button on that one. And now we've got two pistons working. Cool. So these pistons are spinning round and round, and I'm hoping that that kind of looks like that's the source of the power of this whole bridge. I don't know where that's coming from. I don't know, magic. And okay, so connected to these, or it looks like it's connected to these, there's this rod that goes through here and it connects to this gear, and I want this gear to spin at the same rate that these are rotating that shaft. So let's look at how we might do that. So with this gear selected, I'm going to add a new script. Entity add script, new script, and this is going to be called my gear rotation script. And let's open that one up as well. So now we've got active animation script and we've got gear rotation script. And just like in the active animation script, I'm going to use the init function here for the gear rotation script. And notice that the gear doesn't have animations. So it doesn't have the animation that that one has. I can't play animation on this one because there is no copy animation names box. So what I need to do is make my own animations. In the init function, I'm going to do self get entity again. And this time the function I'm going to call is play timeline loop. So if we aren't sure what play timeline loop means or what it looks like, notice that there's this handy hint that comes up, loop a timeline from variable args, see the documentation in the main play timeline function. So if I'm not sure what that is, I can actually go to the Crayta docs at api.crayta.com. Let's go in here. Let's find, so I'm in the context of an entity. Remember we did self get entity. So let's go to the entity. And within the entity, let's scroll down in here and find the timeline stuff. There it is. So we've got play relative timeline. We've got play timeline loop. Here we are. And it's even got this handy example. If I click on that, it shows us this example, which is really cool. So play timeline, let's go back down. We can see that when we play a timeline, you have to pass in a load of things and each of those things has a comma between them. Okay, so this could look a little bit daunting, but essentially this first number is the time since we started playing the timeline to do something. So this is 0 seconds from the beginning of the timeline. And at this point, we want the entity's position to be at 0, 0, 0, and the rotation of the entity to be at 0, 0, 0. Then, at 1 second past the start of us playing the timeline, we want the position to be 0, 0, 100 in the world. So these are numbers which determine the position in 3D space. And the rotation of it to be 180, 0, 0. So 180 on the x-axis, 0, 0 on the y and z respectively. So essentially this will move whatever entity it's attached to. And at 0, it won't move it anywhere. But by the time it gets to 1 second, it will have smoothly moved to that position and that rotation. And that's what we want. And that's how we're going to create these animations. So going back in here, we know that we have to pass a series of values using commas between each one. So the first one was at 0, and that's like our starting point. Where do we start from? And we're going to start from self get entity, and you can either do position or rotation or both position and rotation, and it will Crayta will figure out what you're trying to do. So I can do get rotation, and it won't try and set the position because I'm not doing anything to do with a position. So at 0, we're at our current rotation, and at 1 second, 1.0, we will move to a new rotation. So rotation.new. And now if we're not sure which direction we need to rotate it or which number needs to be what, a handy way to figure that out is to go into the game, click on your rotate tool, and then grab some of these handles and just see which direction it's rotating. You can press Ctrl Z or undo to undo any rotation. So it's not that one, it's not that one, and it is this one. And when I rotate on this green line, notice which number is changing here. So that one, it was the middle number, that one, it's the end number, and this green handle, which is the one we want, it's the first number. And it rotates, and that's the amount of degrees it's rotated. So I want to rotate it 360 degrees on that first number and 0 and 0 on the other two. Okay. So that's our play timeline loop. Let's have a look at that by simulating that. Okay, so the gear is rotating, huzzah! Which is great, it works, but it's rotating in the wrong direction and it's rotating quite fast. So to start with, let's look at that direction. If we're rotating this way, it's because we're using positive numbers and it's rotating right. And we can see that if we use this tool again. So if I pull this handle down and rotate it this way, we can see the number here is going up. If I move it the other way, the number goes down. It goes into the negative numbers. So let's just change this to minus 360. And that will actually change the direction that it spins. And there we go. So now we're spinning the whole cog every 1 second in that direction. Now it's not quite the right speed. So what we might want to do here is just make sure that we can set the speed of these two pistons. So let's go into our animation script and we can actually set the speed, the amount of time it takes to play the animation. And the way we do that is instead of play animation looping, which only gives us the opportunity to have something that loops its normal speed, we can just use play animation, the name of the animation, and then after that end quote mark, but before the end bracket, we put in a comma here, and we can actually do this one with table properties. Now again, if you're not sure what that's referring to, if we go into our docs, go to the mesh. Remember, this is a mesh that this animation plays on. It's not just any old entity, it has to be a mesh. So mesh, and we've got this play animation here, and this really handy example for play animation where we can have a playback time or speed. So we can have a look at that and it looks like this. So this is essentially what we're going to be doing. This looping equals true, playback time equals 1. Let's do that. Open parenthesis, so that's a squiggly bracket, it's not the normal bracket. The looping value will be true, and playback time, the amount of time it will take to play the entire animation, let's set that to 1, end parenthesis. So we're setting that playback time to 1, which is the same amount of time that the gear rotates. It takes to rotate a full 360. So 1 second here, 1 second here. Let's have a look at what that looks like in the game. So simulate that, and let's simulate that as well. And then let's simulate that. Okay, so they're all moving at the same rate. That's that bit sorted. So it kind of looks like they are on the same sort of pole, and that's really what we wanted that to do. So the next thing we need to look at is this gear. Now this gear is a lot bigger than this gear. Let's stop simulating that for now. We can leave those guys doing their thing, that's fine. So this gear is bigger than this gear, and we don't need to figure out the exact size or anything like that. That could get all a bit busy. But what we do need to do is count how many teeth this gear has, because these two gears' teeth mesh perfectly together. So this has 6 teeth, and this large gear here has 24 teeth. So this gear spins at a rate of 6 teeth every second. So in order for this to match up correctly, well, first of all, let's have a look at what happens if we just add our usual script to it. Let's add the gear rotation script to this one, and let's simulate that and simulate that. Okay, so they both take 1 second to make a full rotation, but notice 2 things. One, this is going the wrong way again. And the other thing is, it seems like it's going way faster. It's actually spinning the exact same rate, but because there's so many more teeth, 24 teeth versus 6, it looks completely like it's spinning way too fast. So let's stop simulating these and let's figure it out. This is spinning 6 teeth in 6 teeth per second in that direction. So this needs to spin the other way. It needs to spin in the reverse, because if you think this gear is pushing this gear, so this gear should be spinning in that direction. So to start with, we need to change our gear rotation script so that we can take into account the different speeds and the different directions. So let's do that. Let's create a property at the start that's going to be our end rotation. Type is going to be a rotation. Notice it's a lowercase r there. And end parentheses. And if I save that, we can see end rotation has now come up here. And for this cog, it was minus 360, 0, 0. So let's set that to minus 360, 0, 0. And for this cog, it needs to be positive because we're going the other way. Positive 360, 0, 0 there. Let's use that end rotation. So copy that and paste it in here. Self.properties.end rotation. Okay, so let's just see whether that's changed the direction. Yeah. So if I put a minus at the start here, it goes the other way. Perfect. So we need positive 360 for this one, negative 360 for this one. Okay, positive 360. The other thing was the timing. So this moves 6 teeth every 1 second. So let's add a duration here. Name equals duration. Type is number. Like that. And this is going to be, instead of 1 second, self.properties.duration. So now it's just using whatever number we put into this duration instead of 1 second. So for this cog, remember that was 1 second. We wanted that to spin in 1 second. And for this one, well, this has got 6 teeth. This has got 24 teeth. This spins at a rate of 6 teeth every 6 teeth every second. So there are 4 lots of 6 teeth in this cog. And so when this spins 6 teeth in 1 second, this will need to spin 24 teeth in 4 seconds. So there's 4 lots of 6 teeth here. So where this was 1 second for this one, we have to multiply that by 4. 4 times 6 is 24. So there's 6 teeth here, 24 teeth here. 4 times 6 is 24, or 24 divided by the 6 teeth here is 4. So 4 times the length that this takes. This takes 1 second. This takes 4 seconds. And this is going negative, and this is going positive. Let's simulate those and see what happens. And there you go. So now they look like they're meshing nicely together. And they look like they're traveling at the same speed, even though this is actually taking 4 times as long as this one, because this had 6 teeth and this has 24 teeth. And that's kind of the crux of the getting the gears to mesh with each other, is essentially counting how many teeth they have, and then whichever one you have the time for. So I had 1 second for this 6 teeth one here. You either have to multiply or divide the other one to make sure that it matches. So we've got this now moving 360 degrees in 4 seconds, and this is connected via this shaft to this one. So this isn't meshed, this gear isn't meshed to this one, so we don't have to worry about changing that speed. That speed should be the same for both of these gears because they are connected via a shaft. So let's add the gear rotation script to this one. Let's do the end rotation the same as that one, is 360. And the duration the same as that one, 4 seconds. And let's simulate that. And that looks right because they are connected to each other, so they're spinning at the same rate. This one gets a little bit complicated. This is the worm drive. And so rather than coming at it from a perspective where we need to figure out how many seconds this one takes, we're still going to add our gear ratio script to this one. And notice that I want it to spin in this direction, and that's on the z-axis, the last number. So the x-axis is 90, it's on its end. So we need to keep that. So that's 90 there, so we keep that. But the end rotation for this one, the last number should be 360. And for now, let's just put 1 second there, and let's simulate that and make sure that's spinning correctly. Okay, so it's spinning so that it's going down. So we need that to go the other way. Let's put minus 360. Unsimulate and simulate. And there you go. It's not quite matching up correctly. You can see that these gears are passing through that worm drive, aren't they? So the speed isn't quite right. Now we are going to move, this worm drive is actually moving 1 tooth every rotation. Every rotation is 1 tooth. So where this is This was 6 teeth every rotation. This was 24 teeth every rotation. This was 12 teeth every rotation. This is 1 tooth every rotation. So essentially what we need to do is look at, well, this is moving 12 teeth every 4 seconds. So for 1 tooth, that will take 4/12 seconds, or 1/3. 4/12 is a third. So rather than this taking 1 second, this worm drive should take 1/3 of a second. That's the best I can do for a third for now. Let's stop simulating and then simulate that. And now you can see they don't mesh up exactly because I started them at different times. But when the game all starts at the same time, they will mesh perfectly. And we can see that that is the correct rate. So now the worm drive is spinning at the correct rate of the medium gear. This worm drive is connected to this gear. So let's just add script, gear rotation script. Let's just make sure that that is spinning correctly. So this has got a rotation of -90. Let's just... Okay, so this is going to spin on that axis in the middle. We're going to need to keep that at -90 there. And this needs to be 360. For now, let's just spin it 1 second. Okay, so that's spinning on the right axis. Now let's make sure it's spinning at the same speed as this. This was 0.333. So a third, 0.333. And let's have a look at that. Okay, so that is the correct speed for to be connected to that. Let's just check if it's positive or negative. It should be negative there. Should be negative. Now it all looks a little bit fast. That last one looks like it's going way too fast. So to fix that, what we could do is just change the amount of time everything takes. So multiply it. Let's go to this active animation script. And rather than having this playback time as a hard-coded value like this, let's make it a property. Playback time type equals number. Let's use that there. Self.properties.playback time. Like that. At the moment it was 1 second, wasn't it? Let's times everything by 5. 5 seconds for that one. So 5 seconds for that one. This one was 1 second, so 5. This one takes 4 seconds. 4 times 5 is 20. So now it's going to take 20 seconds. This one was the same as that one, so 20 seconds there. This cog is a third times 20. So for that, might need my calculator, which is there. 0.33 times 20, 6.6. So this is going to take 6.6 seconds. And this one here, 6.6 seconds. And then let's just unsimulate and simulate all of these. It is spinning the wrong way. Oh, no, that one was correct. It's the cog at the bottom that we want to change. Let's just... There we go. Okay, so that's spinning correctly. Let's resimulate this guy. Okay, are these all matched up? I didn't do a little bit of maths here, so these aren't quite matching up. Let's go back to the drawing board. So this is 12 teeth every 20 seconds. 12 teeth every 20 seconds, so 20 divided by, wait, is it 12 teeth divided by 20? 0.66. Should be 0.66. No, this needs to go faster. Okay, let's try that again. 20 divided by 12. 1.66. Nope, not 6.66 for this worm drive. 1.666. Let's see whether that's improved. Wrong one. 1.666. Let's see if that's improved. That's better. Okay, cool. So it's consistent. It's just not meshing completely because they haven't started at the same time. If I wanted to, I could try and time it. There you go. So now it looks like it's meshing together nicely. Let's make sure that's on too. So that's spinning at the same speed. There we go. Okay, so we've reduced the speed of these. Oh, we've increased the amount of time they take and reduced the speed of all these cogs, and now it looks a little bit more visible. So the last piece of the puzzle is essentially to add a movement script to the bridge. Let's do that. Add script, new script, move bridge. And for this one, let's use that timeline again. Self, get entity, play timeline. Position 0.0. The first one will be at its current position. Get position, and then it will move to its end position. So let's just move it to its end position somewhere around there, 775 and 1925, so minus 775. So for now, let's just move it over the course of 1 second. Self, get entity, oh no. And the position we're going to move it to, vector.new, minus 775, 150, 0. Let's just simulate that. Okay. So, and that's going to move correctly to the right place. So now we just need to move it at the right speed. Now, how many teeth are on here? Well, there's 9.5 teeth on each of 9.5 teeth on each of these racks, and I basically calculate it to be 46 teeth in total to get the bridge across. So if there's 46 teeth, this is spinning at a rate of 1.66 for 12 teeth. Woo! So this takes, so this should take 6.363 seconds to move across. Let's see whether that looks right. And there you go. So the teeth nicely meshed together. It's just using the same formula each time. So you look at how many teeth per second that something is moving. So this was spinning. This was having 12 teeth every 1.666 seconds. So 12 teeth. So one tooth takes 1.66 over 12. Times that by 46 teeth for this bridge, and that's how fast it should move. So there you go. That's how we can essentially make all these gears click together correctly. The thing you're looking for is that how many teeth per second number, and once you have that, you can start to mesh them all together nicely. And now if I wanted to, I can make this gear rotation. I can create a new function in here, gear rotation script activate, move this functionality into that activate function, and then call that only from this interact here. So now we would just go through, and each of these cogs be added to that interact. So we've got gear straight here. It automatically selects gear rotation script, and then we select the activate function. So go through and changing all of those, adding all of those cogs, and the same with the active animation script. We would create a new function here, function, active animation script, activate, and essentially take this and only play that animation when we started. So that was gear piston large. So again, with this selected, on interact, we now would just drag our gear pistons onto a binding here and activate those. So activating each of the gears, and the same with the bridge. So let's click on the bridge, stop simulating the bridge, move this to a new function, move bridge, activate, and play that timeline only when we have activated it using this. So with this selected, we just move the bridge, add a new binding, and move the bridge onto there and activate it. So basically going through all the cogs, adding them to the on interact function, so that when we walk up to this, control panel and interact with it, you can see it starts some of the cogs working. I haven't added them all to the script, but eventually, now that I've set up all the timings correctly, I can add them all to the script and that will do that thing. In order to stop the cogs from working, so they are playing now until we ask them to stop. So in order to stop them from working, we can add a stop function to our gear rotation script. Gear rotation script stop. And here we do self get entity, play timeline loop, and we can just give it the first property like that. And the same with the move bridge. The move bridge will stop automatically. And this, by giving it only one keyframe at position 0 and putting it on a loop, it means it will be stationary in that position. The same with this animation here, function, active animation script, stop. To stop this, we can do self, get entity, cancel, no, stop. Play animation, and we'll play the deactive one, which is the one where it stopped. Play animation, yeah, like that. So we have these ways of stopping the gears and stopping the animation. And you can kind of hook it up however you want to. You could time it so that it's timed exactly as how the bridge moves across. But one other way you can do it is by using a trigger like this. And essentially when something from the end of this bridge, I don't know, this particular thing, factory column base 5, when that crosses into the trigger, we will then call an event to stop that. So with this one, we would just check if the thing that has entered the trigger is equal to factory column base 5, then send this event. Notice I've created this property already. Self.properties.bridge complete send, like that. And then I can just hook up the gears to that event. So this bridge complete event, which is attached to this trigger script. So I've got a trigger over there. I've added a trigger script to it. I've created one property in that trigger script called bridge complete, and it's of type event. When the factory column base 5 enters that trigger, then it will send out that bridge complete event. And that bridge complete event essentially needs to hook up to the same things that have been hooked up to this thing. So we've got gear straight spur large 1, which is that. Yeah. So the trigger needs to stop that one. Gear straight spur large 1, stop. And also the pistons as well. So the piston needs to stop too. The bridge will stop on its own because it's already on that timer. So if we just have a look at those two things, when I interact with this console, all of the cogs will be working and the pistons will be going round and round. and then the bridge comes to an end and they should stop. Okay. The one problem here was I was checking an entity against a string. I needed to get the name of that entity and then send out that function. So checking the name of the entity against whatever has entered the trigger. So a bunch of things will be entering the trigger at the end, but to make sure I only call that function once. And there we go. The cog stopped and the piston stopped and the bridge has stopped, and I can get over to the other side. Now it's just a case of polishing this up. So starting a sound, maybe starting some steam, some steam effects, some sounds, adding the rest of those cogs to the interact as bindings to the interact function for this console, adding the rest of those cogs to the on bridge complete event. Yep, bridge complete event on the trigger. Once they're all hooked in together, essentially I'll have my retractable bridge. Hopefully you've enjoyed looking at the cogs and looking into a little bit of the maths around getting these guys to mesh together nicely and to move sweetly. I really look forward to seeing how you use this, and if you get stuck, don't forget to head over to the Discord. Let me know how you get on, and I look forward to seeing you in Crayta.